All right, ladies and gentlemen, back to Unit 12, Nuclear. Now we're doing 12.2, and we're talking about artificial transmutation. I want you to take a few minutes, and I want you to copy this into your notes. We'll talk about artificial transmutation, which is different than natural transmutation that we talked about in video 12.1. With artificial transmutations, this is not a spontaneous process, and it means that man had to do something in order for this transmutation to take place. Okay? You're going to recognize the difference between natural and artificial transmutation is that in natural transmutation, we only had one particle on the reactant side or the left side. Now we have two particles on the left side of the arrow. Okay? And then we have two or more new particles appearing on the right side of the arrow. In this case, we're using Einstein's energy equals mass times the speed of light squared, and it tells us that we have mass being lost and it's being converted to energy, and that's how we get radioactive bombs. We're taking mass and we're making enormous amounts of energy. Okay, so take a second, pause me, and copy all of this stuff down. Then I'm going to go through these three very simple artificial transmutations: nuclear disintegration, fission, and fusion. Okay, I grabbed this artificial transmutation from the other page, and I want to point out just one more time that if we have, I need a highlighter here, or I'll take a pointer actually, If we have two light nuclei, in this case a lithium and a neutron, and we get the neutron to hit that lithium nucleus hard enough, we can get that nucleus to change. And that's another transmutation, changing the nucleus. We're going to do that by taking, I need a pen again, a lithium with an atomic mass of 6, and we're going to take a neutron with an atomic mass of 1, and we're going to transmutate them into a hydrogen with a mass of 3 and a helium with a mass of 4. Now notice that the masses add. 6 plus 1 is 7. 4 plus 3 is also 7. And then the charges on the bottom, same thing. You've got lithium with a nuclear charge of 3 and a neutron with a charge of 0. And here we have hydrogen with a charge of 1 and helium with a charge of 2. Both sides add up to 3. The biggest thing that they're going to ask you about, now that I scribbled all over this, is this natural or artificial transmutation? You're going to know that it's artificial transmutation because I have two reactants, whereas with the natural transmutations, I started with one reactant, and they were listed, the natural ones were listed on that reference table. I think it was table N. I don't remember what letter it is. Okay. The second type of artificial transmutation, the man-made transmutation, is called a fission reaction. Now, fission reaction takes a radioactive isotope like uranium, and that uranium is bombarded with a neutron. Let's get a pointer so you can see what I'm looking at. Okay? And when that uranium is bombarded with a neutron, you get an atomic bomb. That uranium breaks apart into barium and krypton and 3 more neutrons. Memorize this equation. It is an artificial transmutation, and what happens is it gives off plus, I don't have any room here, let's see, oh wait, I think I can do this, plus enormous amounts of energy. Huge amounts of energy. This is the atomic bomb. These are the kinds of bombs that were dropped on Hiroshima and Nagasaki. Okay? They give off more energy than any exothermic reaction we talked about in the past. Is you are taking energy, well, you're actually taking mass, multiply it by the speed of light, and making huge amounts of energy. Okay? So it's it's a, how do you say this? It's a chain reaction. If you have a uranium, this is a hunk of uranium, and you hit it with a neutron, that's a neutron coming in, hitting there. This uranium is going to break down into barium and krypton and 3 more neutrons. Neutron, 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 0, 1, 0, 1, 0, 1. Those 3 neutrons then go on to hit more uranium. That's more uranium. See my little drawing there? Isn't that cute? And then these guys break into barium, krypton, and 3 more neutrons. And it keeps going, 0, 1, 0, 1, 0, 1. It keeps going over and over and over again. And I like to think of it as like the little mushroom crowd. You start with 1 neutron hitting, and the next thing you know, you have 3 neutrons coming back out. And then those 3 neutrons hit more uranium, and now you have 9 neutrons coming out. And it's exponential growth. It gives off huge amounts of energy. They might ask you about the difference between a regular chemical reaction and a nuclear reaction. Well, nuclear reactions give off enormous amounts of energy. Okay, so this is the atomic bomb that we dropped on Japan and basically annihilated and ended the war. Okay, now we have one more type of artificial transmutation that's called a fusion reaction. Let's go to another page here. Fusion, I'm going to pause you so I can write them down. All right, so I wrote them down. Hey, how come I can't zoom in now here? Okay. There we go. That's better. Fusion reactions are a little bit different because now we're taking light nuclei, very light, like hydrogens and heliums, and you'll notice that all of these things on the reactant side have hydrogens or heliums only, and we are making something that is bigger than what we started with. So fusion takes small nuclei and fuses them together to transmutate them into something heavier. Whereas in the fission reaction, we took a heavy nucleus and we hit it with a neutron and we broke it into barium and krypton that were smaller nuclei than what we started with. So fission, we took something big, we made it into something small. Fusion, we're taking something small and making it into something bigger. Now, they're not big, but they're bigger than what we started with. These also give off enormous amounts of energy. Okay? You don't have to memorize these. What you do need to do is be able to recognize them. You need to be able to recognize the fact that you have hydrogens and heliums on the left side. There's two reactants, I should say, and they're coming together, fusing to make something bigger. What was I going to say? Oh, this is the H-bomb. Hey, I don't like that pen. The H-bomb. It's a little bit different than the atomic bomb. They give off enormous amounts of energy. It was used to annihilate the Bikini Island when they were testing them. So they also give off enormous amounts of energy. You need to know that. Okay, and you need to be able to recognize these. Okay, so I think that pretty much sums up artificial transmutation, and we did natural transmutation in the last video. So just to recap, natural and artificial. Natural is alpha decay. It's beta decay. It's positron emission. Oops, spell it right. Artificial is going to be fusion and fission and nuclear disintegration. Let's just write that down. So how are you going to tell the difference? Natural will have one reactant becoming 2 products, and artificial will have 2 reactants to 2 or more products. That's how you're going to know the difference. I ran out of room here, but you get the idea. Okay? You always have, these guys give off enormous amounts of heat. These are your bombs. Okay? So compared to a regular chemical reaction, the artificial transmutations are the ones that are going to give off lots and lots of energy. Okay? Oh, I don't think I mentioned this though. Fusion is the H-bomb. Yeah, maybe I did say that. Fission reactions are the atomic bombs. And I know I didn't say this. They're also used to power nuclear power plants. Okay, so fission reactions are controlled reactions, and you can control them so that you can harvest the energy that nuclear reaction is taking place. And if you can obtain that energy, you can then turn the turbines in your nuclear power plant. And when I get back, I'll show you a little video. When you use that energy to generate the power, then you can disseminate it to the consumers. So fission reactions are used in nuclear power plants. The uranium reaction, the one that said uranium plus a neutron gives you barium, krypton, and 3 more neutrons. Okay, so this is 92, 235. Okay. All right, that's a very quick synopsis of Unit 12.2. That's artificial transmutation, man-made transmutation, because the fusion and the fission do not happen without men getting involved. All right, the next video we'll talk about half-lives.